Hello and welcome to another episode of PreSales Insight. Today with the AI impact on data center. My name is Sascha Oehl, a tech sales or pre-sales leader in EMEA, and I will give you some insights today on the changes AI brings to the data center. Changes from a design and an operations perspective. A change which is imperative in the evolution of data center and often not decided by the IT departments. Therefore, we will have a look in the role of the data center for today's business. Then we will have a look into the new AI workloads and the consequences they bear for data center requirements. The next step will be to see how AI is supporting us in plan and run data center and the job requirements that are in a constant change to meet the requirements. So, what is the role of the data center? No doubt, it is the heart of the industry of the modern age. It delivers the constant heartbeat, the processes and the decisions needed to run a company. An outage of IT is usually equivalent to an outage of the company. The design of the data center is driven by those requirements. The reliability to have IT systems up and running, the need to scale when needed, the ability to store, process and distribute data while meeting security requirements, protecting the information. This all worked like a clock and every wheel was perfect, or close to, adjusted to fulfill the requirements. In all this peaceful landscape, suddenly change appeared. AI workloads entered the application landscape and are quickly adopted by users. Large language models, machine learning workloads, deep learning and natural language processing, image interpretation and robotics are part of our modern life, at home and in the company. In the beginning, those functions entered the data centers often in stealth mode, as an update to an application, just another function, changing the workload characteristic dramatically. Then there was a planned process to add another AI component, another functionality to the applications. This changed requirements for the data center. Different hardware is required to drive maximum benefit. The design of the data center needs adjustments. New protocols are implemented. On the other side, the data center design and run teams always use AI to get better designs, respond to security challenges quicker, and automate operations. This all came in addition to the classic data center challenges, like managing the power and cooling, managing scalability, and all the other daily tasks. We have new workloads with other requirements. Let's have a deeper look what those requirements are and how we can satisfy them in a data center. We will look at it from a processing and a storage perspective. What changed on the processing side? It is not just another server. It comes with different components and it's highly optimized to do the exact right job. This component for this job. Some changes are very present. We saw GPUs, graphic processing units, which never were part of the data center, became important and are now part of designs, data centers and implementations. They support tasks like deep learning and inference, highly parallel, supporting matrix operations to run neural networks. Well-known examples are NVIDIA's Tesla units or AMD's Radeon cards. But there's much more. TPUs, for example, tensor processing units. TensorFlow was developed by Google's Brain team as a cornerstone for training and interference with deep neural networks. It requires special processing operations, especially matrix multiplications. That can be done in standard components, but this is slow and consumes a lot of energy. To speed it up, Google developed specialized chips, an ASIC called TPU, Tensor Processing Unit, to increase the speed dramatically while decrease the energy consumption. It has lower precisions than other processing units, just like 8-bit, but this is what's needed to do the job. And it's fast, and the energy profile is very low per operation. Those TPUs are used, for example, in Google's data centers for automation tasks. And when we speak about specialized hardware, the next two must not be missed: FPGAs and ASICs. FPGAs are field programmable gate arrays, a special beauty. While other chips come with a design and a work method and everything is implemented in the factory and it's set for the whole lifetime, those FPGAs are chips that can be reprogrammed in the field. You can adjust the behavior to the needs and get great performance with low energy consumption. It can be adjusted to the task the AI really needs, especially used in real-time operations like speech or image recognition. There you will find a lot of usage of FPGAs. Lastly, let's call it the other ASIC. The TPU, for example, was an ASIC. An ASIC is an application-specific integrated circuit. So an integrated circuit or processor that is optimized for specific tasks of an application. While a CPU or GPU can be used for generic tasks, those ASICs are designed for very specific tasks. Kinda the specialist version of a processor. In our case, specialist for AI operations. When we talk about those four groups, they all come with different heat and power signatures, which requires a data center to adjust the designs. And of course, they are data hungry. When you spend a lot of money and buy those units at scale, you want to ensure that you make the best use of it. Definitely, you don't want them to idle around waiting for data. We all know in a system there is always a bottleneck. The one component which is affecting other components with its performance. Running the AI task on generic hardware, the bottleneck was usually the processing unit. Now, with the discussed options, this bottleneck is removed. Now, what's the next slow part in the system? It becomes data delivery. Reading the input data from a storage, sending the data through the network just in time was a challenge. Luckily, the storage community was prepared for it. First of all, NVMe SSDs for high-speed storage, increasing the performance by factors over hard drives, especially with random small block patterns. That move helped a lot. Now we were able to get a lot of small blocks and deliver it to the processing unit. To do this at scale, we needed the right storage arrays. The storage arrays with performance and capabilities. The scale was needed to house all the training data. Those arrays come with low latency protocols like InfiniBand or Roki to ensure the numerous small packages of data are delivered to the processing units. So housing a lot of data and being able to respond super fast. And if this is not fast enough, last but not least, for specific cases in memory computing. Large amounts of RAM host the data right next to the processing unit. removing massive amounts of latency. But, of course, it comes with a price. This is really expensive. All this sounded probably a bit like do-it-yourself, but this is not the case. Pre-designed solutions like NVIDIA's DGX systems, for example, come with a clear design, a clear amount of GPU processing power, a design that scales. Just for example, look at the DGX SuperPod, a complete design of processing nodes combined with SuperPod capable or certified storages to build a supercomputer in your data center. Currently, you find those designs in the top 10 of the world's supercomputers top 500. For example, the EOS SuperPod. The beauty is, it runs with less cores and is very efficient. Your data center requires probably a lower number of nodes, but it's great to see that the design you start with can scale if needed. A bunch of toys, great hardware we all want to have, we all want to use. Now let's have a brief look into the planning and operations with AI. First, we have the green look, power and cooling. And there are obviously aspects to it. On the one hand side, there's an increased need to power and cooling due to AI. And with the specialized hardware, this can be reduced to a lower increase. Nevertheless, the data center gets new heat signatures, hotspots at specific points, a high demand of power and a lot of heat at specific points in the data centers. This requires optimized energy design and, more difficult in many cases, an optimized design to get the heat out of the aisle. The good one, someone else already had the problem before. You can build on that experience. Liquid cooling, for example, a technology that had been in data centers in the early mainframe age, and immersion cooling can help to mitigate heat spots and support the AC design efficiently in the data center. With those concepts, you can get rid of heat spots and run it where you are. Now, you have the AI hardware in the data center, and it's cooled, it's powered. How can you make use of it from a data center point of view? Let's look in some areas. One area is adaptive infrastructure. It builds on workload mobility, which means you can move a workload from one infrastructure to another while it's running. VMware's vMotion, for example, was one of these early technologies that made this possible. Now you find those capabilities in many products. And it brings not just mobility within the data center, it includes the cloud. But there's more mobility. Think of auto-scaling for specific machines or dynamic provisioning of hardware to adjust the hardware to the current needs. For sure, you don't need to give it to an AI. You can try doing it on your own, but sneak peek, you will lose compared to an AI. The AI is working 24/7 and is able to calculate much more variance. The AI is learning quickly from the workload patterns it is analyzing and adjusting it to the resources to the needs in an optimal way. Sounds a bit too much futuristic? Too much sci-fi? Then have a look at AWS EC2 recommendations, for example. Via an AI, you get recommendations for the EC2 design or type based on the workload pattern that they discovered. And in the backend, the data center is always optimized. This improves cost and performance by making the best use of the installed hardware. And there is more, just to highlight some more items where our AI is delivering benefit in the data center. Automation and self-healing, for example. With the discussed mobility, the AI can even in a disaster automate and make the best of the left resources. Without manual work, without manual errors. in a disaster, and of course, also in daily operations. Or think of predictive maintenance. AI can predict potential failures and start proactive maintenance based on the data of sensors. And we all know every compute node, every storage node, every switch is packed with sensors. Using those sensors, degradation is detectable and maintenance can be scheduled for a time window that fits best before the problem occurs. And for example, resource optimization. Based on the patterns it detects, it can adjust the airflow and temperature for cooling or even the power distribution to run the data center more sustainable, more environment friendly. And for sure, also on the security front, we are benefiting of AI. Threat detection. AI can compare patterns of behavior and see anomalies based on the access or activities. This helps either to start automated countermeasures immediately or to suggest measures a human operator can execute. Both reduces the time to react and the exposure to risk. Same applies for real-time monitoring and response. The campus is packed with cameras, but a human operator cannot watch them all. The AI can, and it can see moves that are so fast that an operator could barely see them, analyze them, and respond to them. Same applies to behavioral biometrics and access. Is someone accessing doors they never did before, or in a suspicious pattern? Difficult timing? Worth to have a look into it. AI can give us the right hint, which leads us to threat intelligence. This is a great point where everything comes together. AI is working to different threats in combination with the knowledge of your data center. From those, the understanding of the threat and the knowledge of your data center, it ranks the risk high to low. So even with limited human resources, the responses can be adjusted to the real priorities. All this, probably again, not rocket science. Humans did it before. But with AI, it is done 24/7. It is done multiple times per second. And no reduced quality just because it's perceived boring. Always quality, always on. An example for this could be Google's AI-powered security. Google uses AI for data center security, while DeepMind is optimizing power and cooling and adjusted to stay in safe boundaries for security and safety of the data center. The Cloud Security Command Center uses AI to detect and respond to threats on a global base. Before we move on, I want to touch capacity planning for a moment, a process which usually involves ordering components based on the current needs and the predicted future. This includes a lot of variables and is often driven by gut feeling. This kind of planning can be costly. Resources are bought too early, too much, too less, or too late. But as better you can do it, as better your price per unit is in the end, and as more benefits you deliver to the business. Here is also a lot of AI help, and those are three fields going hand in hand with planning. It starts with demand forecasting. Based on our knowledge from the past and what we expect to happen in the future, the workloads detected, it calculates something that we could expect for the future. This part is often very difficult for a human being, just because it's a lot of data. Then we can, on top of it, add scenario modeling, like what-if scenarios for data center to see where will we end and see if we build as a dead end in our forecasting-based procurement option. Like, what if we buy another company? What if this service goes up? What if 30% goes into the cloud? All these scenarios can be factored in. And as a topping, we can add energy efficiency. Like, what are we consuming on energy now, with what costs, and how would this look like in different scenarios? Is it probably worth swapping more or less to get the optimal price, to see where we can reduce power consumption? Where could we meet the price challenges that we have and being environmentally friendly? This process helps us to drive sustainability goals without killing business goals. An example of this balance can be DeepMind. With the associated optimization and the cooling effects that come with it, the optimization saved up to 40% of the money and the resources. This was a dramatic impact for the environment. It's like barely half of the data center. Of course, all these new technologies, all these new functions, there is an impact on the jobs and the skills needed in the market. For us, it's crucial to adopt, to build up this knowledge, to stay competitive. AI is definitely making some skills obsolete over time. On the other side, it requires other skills. So good we have time and we can do our learning to be highly skilled for all the scenarios. For the future, we need knowledge to operate AI and to use AI for planning, for example. This is something where we have to build skills. Also, the infrastructure architect that we already knows and is taking care of the data center comes now in combination with AI skills. On the one hand side, to ensure smooth operations with AI capabilities. On the other side, using AI functionalities to even more improve the data center. For all of them and most other roles, it becomes critical to either design algorithms or to understand data analysis and the tools. How we use the data, how we use the AI. We have to learn how to interact with the AI to make the best use of it for the business. This is a learning process, and it's best to learn it early. You probably feel remembered to your first experiences with ChatGPT and how your prompts got better over time when your experience levels got up. In the last minutes, we have had a brief overview of AI and data center. While we know how important data centers are for the business, we know that change is coming and must be factored into our planning. With those new workloads, the AI workloads, we have a lot of new hardware components in the data center. Or was it GPU, TPU, FPGA, ASIC, with a high storage need for fast NVMe storage with ultra-fast protocols like Roki, InfiniBand to communicate. This requires data center planning with new cooling concepts, where AI can help us to design best possible. We saw that mobility, security and capacity planning, for example, can benefit from the AI power. And yes, we all need training to make the most of this opportunity in front of us. Thank you for giving me your time and listening. If you have feedback, put it in the thread or send me a message. Now I want to say, enjoy your day. See you in the next PreSales Insight session. My name is Sascha Oehl, and I'm looking forward to see you again.